Ladies and gentlemen, I will describe a fire risk index method that we developed to analyze fire risks in timber frame multi-story apartment buildings. The background is that there was an project carried out on fire safety on multi-story timber frame buildings, and we wanted to quantify, measure, is house A more fire safe than house B? And we wanted to compare different strategies. Should we put in sprinkler or detection system? Is it safer than a concrete or less safe than a concrete building, and so on. And so we developed a fire risk index method for multi-story apartment buildings called FRIMMAB. This is the project organization. There was a steering group, a project manager. We had an expert group of 3 internationally known experts, but we had a project group of 5 Nordic experts and a Delphi panel with 20 Nordic fire safety professionals from the insurance industry and design, fire brigades, management, and so on. This is how we organized the method. We start by defining policy. We want to have an acceptable fire safety level. We then go into objectives. The objectives were to save lives and protect property. We had strategies. We're going to have active fire safety to limit fire growth. We're going to have passive fire safety. We're going to have safe evacuation and safe rescue operations. And this led us to 17 different parameters that we wanted to test on suppression systems, on the fire service, on compartmentation, on separating structure, and so on, doors, windows, facade, attic, and so on and so on. This is an example of one of the parameters. Just to give you an example, this is the parameter P2, which is suppression systems. There are sub-parameters. There's a parameter for automatic sprinkler systems or sprinkler systems. Now, if you get a very good mark from that, if it's an automatic system, it's in the apartments and in the escape routes and so on. So you get a high mark, H, a high mark. We then also check the extinguishers. Are there extinguishers there? Are there not? Where are they? Are they on every floor or not? If you get a high mark from that, then your risk grade, you get a high mark, which means low risk, basically. So you get a best mark for very good safety. Now, it took many years to develop this method, and then it was tested extensively. There was a reliability test. We tested against a much more complicated quantitative risk analysis calculation and a design method. We tested it on 4 different buildings. We checked what the limiting index was for the building codes in each Nordic country. So using the minimum requirements in the building code, what's the highest risk that we are allowed to have. We also did repeatability tests. So we took 4 different multi-story apartment buildings, gave the drawings to 5 different Nordic designers, and we asked them, please evaluate the fire safety using this methodology. And the repeatability was very good. All 5 engineers evaluated the risk in a very similar manner. Just to give you an example of some of the results, we tested 15 different timber frame multi-story apartment buildings. Minimum demands in the Swedish building code was determined to be about 2.75 out of a highest. The riskiest one was 5. Low risk is good, high risk is bad. And applying the minimum requirements in the building code, we found that the Swedish code wanted no higher risk than 2.75. And we see that out of the 15 buildings, 2 of them with the risk index 2.88 and 2.95, they actually exceed the risk you're allowed to have in the building code. The other houses were pretty good. I just want to show some of the publications. I mean, there are a lot of publications on this. I'm not going to read this up, but there's a lot of literature. And we have two handbooks that have been given out. There's a European handbook given out in 2010. Within this Nordic wood fire project, we worked also on a Nordic Baltic handbook in all the Nordic languages, all the Baltic languages, and in English. In that book, we have a more relation to the building regulations and more examples. The latest edition is version 3. Finally, I'll just show one of the many applications we have. There's a case study. We did a case study. We tried 4 design alternatives. We tested it on an existing 6-story apartment building made of concrete. So the concrete frame building got a low index value of 1.89. But when we made it out of a timber frame, it was a slightly higher risk index, 1.98. We then put a timber facade on the front of the timber frame building, and the risk index is increased to 2.14. But then we tried to put the timber frame and the timber facade, and this actually gave us an index value which was lower than the concrete frame, so it's 1.83. So the lowest risk, the best building was actually timber frame plus timber facade plus sprinkler, very similar to the concrete building. This is just an example of how we can use this. This is just an example of how to use the methodology. Now, this paper has outlined a methodology for developing fire risk index methods. We've described the development and the testing of one such method, FRIMMAB. We've shown how the method was evaluated against more complex quantitative risk analysis techniques. We described how it was tested on 20 different buildings in the Nordic countries and found the limiting index value for the building code in each country. We show how 5 different engineers used the method to analyze 4 different buildings, indicated that there's a good repeatability. And finally, we gave some simple examples of how you can use the method in different design problems. You compare a concrete building with timber frame with various different design approaches, so wooden facade, sprinkler system, and so on and so on. And so, thank you very much for your attention. More information, please write to the address. Thank you.